Hey community, on this episode of Behind the Tech, I chat with Ryan Johnston, the CEO of Applied Aeronautics, maker of the Albatross, the PX4 based fixed wing. Ryan has been a part of the community for over a decade and he's a huge PX4 supporter. Stick around and find out why Applied Aeronautics chose PX4.
And we had assets all over the country and things like this, and we needed drones. We wanted them at least. We went out, we put a little team together to look at kind of what was commercially available. There wasn't much, or it was super expensive. We kind of were faced with two problems, or a dilemma, I should say. It was spend a huge amount of money for something that really didn't have any sort of proven ROI. We didn't really know what we were going to get out of it, what we could or could not do with it, or use commercial tech that we had no idea if it was even going to work. So it was kind of like, well, do we use something that's very expensive or do we use something that's probably not going to work?
Yeah. You had a customer already in mind, or
no customer in mind.
Just exploring.
No, I was committed. We're not even exploring it. It was not going to.
So you
not
knew
happen.
that there was an opportunity, you wanted to go for it.
Absolutely. I figured that if we build it, they will come.
And they did.
They did.
Hi everyone, welcome to another episode of Behind the Tech. I am your host, Ramon Roche. I'm the general manager for the Drone Code Foundation. Thank you for watching, and make sure you subscribe to our YouTube channel and like this video, and turn on the notification bell so you can be notified whenever we upload the new stuff. And I'm joined today by my special guest, Ryan Johnston from Applied Aeronautics. Thank you for accepting the invitation.
Well, thank you for having me.
We're really excited to have you here because we are going to talk about drones.
Great.
Our favorite topic. So, Ryan, I want to give the audience a quick overview of who is Ryan, because I think it's a really important thing to know. Who is it that is the person behind all this cool tech?
Sure. So, my name's Ryan Johnston. I'm CEO of Applied Aeronautics. We are a fixed-wing manufacturer based in Austin, Texas. We've been around since 2014, but going a little bit back behind that, my background's actually originally finance. So I started off in different finance positions in natural resources, really. And I ran an oil and gas company. And we had assets all over the country and things like this, and we needed drones. We wanted them at least. 2010, around there, to do surveying and things like this. And we went out, we put a little team together to look at kind of what was commercially available. There wasn't much, or it was super expensive.
What year was this, sorry?
Around 2010.
2010? Okay, yeah.
Maybe 2011.
So I can get a lay of the landscape then.
So we kind of were faced with two problems, or a dilemma, I should say. It was spend a huge amount of money for something that really didn't have any sort of proven ROI. We didn't really know what we were going to get out of it, what we could or could not do with it, or use commercial tech that we had no idea if it was even going to work. So it was kind of like, well, do we use something that's very expensive or do we use something that's probably not going to work?
Yeah.
No one's going to do it.
Or that it's going to be a lot of maintenance.
Well, maintenance, but I mean 2010, right?
Yeah.
We had no idea, I don't think.
Yeah, maybe you go to DJI or...
But 2010s, yeah, exactly. 2010 DJIs, people were still complaining about flyaways and things like this. You know, it's
scary.
It's a scary thing.
And were these locations where you use them, was it like remote?
Everything was remote. So we had assets all over the place. We predominantly owned oil and gas wells and things like this. So there wasn't, there weren't a lot of people around, but still to cover large distances and things, to do it in a meaningful way, it was a challenge. So fast forward, we didn't use them, things like this. I ended up getting involved by funding Applied Aeronautics as a passion project. This was 2014, a couple years later, and I'd always been interested in aviation, and I said, listen, this is something that could be really great. There's predominantly only quadcopters out there, and we needed long-range platforms before, and it kind of built from there. I mean, that's really how we started originally.
So you had the need at this oil and gas company.
Yes.
And you were looking at more like an end user.
Absolutely.
I need the data capture capabilities of this platform.
Surveying, scouting, all this sort of thing, and it didn't really exist. Or it did exist, but we didn't know at what true cost.
Yeah, and I think you're the first guest at the podcast that is actually manufacturer of fixed wings, we've particularly only spoken with companies that actually build the flight controllers or multicopters, and you're the first one that actually does fixed wing. And I want to pick your brain on that platform because I think and my audience can correct me if I'm wrong, but I think that there's not a lot of people out there that have mastery of this platform. And I know that you're very passionate about this topic, but so let's take it by steps. So,
Okay.
oil and gas company, and then you're like, you know what? I'm very passionate about flying and this new technology, and you're like, okay, I'm gonna give it a shot.
Well, like once I'd sold that, right, I wanted to do something. I did a few other things, and I was like, okay, this is going to be fun as a project, right?
What were you like geographically located by then?
Let's see. My oil and gas company was based out of Houston, Texas.
Yeah.
I lived in Australia for 2 years or so, working in resources, and then I came back to California, and I wasn't really working on anything too specific, but I really had always been interested in the drones and technology, and since a little kid, interested in aviation.
Yeah.
I mean, that was like a passion of mine.
What year was this?
2013, 2014, right around
so
there.
it was like drone industry was barely getting started.
Absolutely.
Yeah.
Right time. It was the right time. So then Applied Aeronautics came together, and we designed, the company designed the aircraft, the airfoils, every aspect of it, which is a big difference that we had seen, form versus function, right? Some of these foam-based planes that we'd seen out there, someone sketched them out, that's about it. Looked cool. But
I mean, everything that was available back then was mostly because of the RC community.
Yeah.
And everything came out of there, and the same vendors that catered to them was like, oh, all of a sudden, just change the electronics and you get a drone.
And you get a drone, yeah. I think that's an interesting thing, because with the expectation of an RC product or an RC user is very different than, especially now, a commercial user or a military user. But you started to see even back then things that were tailored or done a certain way, function-wise versus form, how things, durability, this sort of thing. It was really interesting to kind of go through, as a manufacturer, go through the process.
So you went into the drone industry and you're like, I'm going to manufacture my own vehicle, because you saw that there was nothing else that anyone could use.
Absolutely.
And you had a customer already in mind, or you were
no customer in mind.
just exploring?
No, I was committed. We're not even going exploring. It was not going to
So you
not
knew
happen.
that there was an opportunity, you wanted to go for it.
Absolutely. I figured that if we build it, they will come.
And they did.
They did. And then we did have a customer come in 6 or 8 months later and order 255 ready-to-fly aircraft within 6 or 7 months. A single customer. And so that was interesting, because that was late 2014, maybe early 2015, right around there. But that was kind of proof that, hey, there was something here. There was the possibility for this to actually be meaningful.
Yeah.
And that's one of those things that for me was like, okay, now let's expand upon this. What else can we do? Where's the software? Where's the technology? How far along are we? What do we need to do? What do we not need to do? Which is an interesting story of how we got to PX4.
Yeah. I mean, I was going to ask, what flight controller were you using on those vehicles?
Okay, so we always started with Pixhawk 1s.
Yeah.
Pixhawk 1 was already
the original,
around.
the classic?
The classic.
Yeah.
And we
Long live the king.
I mean, honestly, we can put one in the plane now and it will fly great. And what's interesting is we started with Autopilot, and there were, there was no flaps and crow at the time. So ailerons up, flaps down for us to slow down.
Yeah.
And our aircraft has an incredibly high glide ratio, around 30-1.
Was this the Albatross?
Yes.
So it's always been the Albatross.
Well, here's the thing. We've always called it the Albatross, but we've made modification, iteration after iteration after iteration.
I've never seen one in person. Okay. I missed my chance in Austin, but in photos it looked like the same one always, and I don't know enough about fixed wing.
Well, yeah, okay.
So the longevity of the frame.
Well, here's the thing. We designed the aerodynamics, even the airfoils. So we spent a lot of time doing that, and we wanted to make sure that we did not change the aerodynamics that much, even as we increased or changed iterations, material usage, component usage. We tried to keep the outside as little as possible change-wise.
Is that because you want the user experience to remain
actually the opposite.
similar?
I think user experience probably wouldn't so much be that much of a difference.
Yeah.
It's really that it's such an efficient aircraft. It can fly for 4 hours. It's electric. It all came down to efficiency, and that's really what kind of drove us. 2 things in the beginning: efficiency and cost. We wanted to make sure we were inexpensive relative, and we wanted to make sure that we could fly for an incredibly long time.
Awesome. And you were always using open source since the beginning?
Since the very beginning.
Great. And then you mentioned we got building and developing. So how many people were there at the company but then?
In the very beginning,
were you still in California?
We started in California, yes.
Okay.
The very beginning there were 2, and then about
a bunch of contractors helping out.
Within 4 months there were 3 of us, and then contractors has kind of always been the way to do things. Especially in open source and things like this, where you're not 100% sure if it's worth even investing time or resources.
Yeah, you can do a quick prototype, pay someone, pay a developer. Hey, pay your developers.
Yeah, absolutely. And we actually flew to Switzerland to meet with a bunch of the PX4 kind of maintainers at the time.
Yeah.
We brought
like
a couple.
Sylvan, Roman.
Let's see. Roman actually wrote a bunch of the initial code.
Nice.
For auto takeoff.
He's a genius. Hi, Roman.
Hi, Roman.
Thank you for everything.
And Andreas, who I think is and Simon Wilkes as well back then.
Wow.
Yeah, long time ago.
Yeah, the original gang.
Yeah. So we flew there, and they had auto landing and auto takeoff working on the first flight. It's still posted, actually, I think, on PX.
I've seen it.
That's like day 2 or something like that.
Go to the YouTube channel on PX4 and you'll find it.
It's pretty cool to see, and the interesting thing is that's actually at a live, active airport. We just kept radios. But within a matter of days, they had that working.
Awesome.
Which is testament to PX4 and one of the reasons that
you chose PX4.
Absolutely.
So you got this beautiful platform.
Yeah.
You got a lot of customers. You got your Pixel 1. You got your Autopilot on it, and you already kind of spoiled the surprise, but you changed to PX4. Like, no surprise, you're on the Behind the Tech podcast. But how was the decision-making process behind moving from one platform to another?
Well, it was not even a decision.
Okay.
It was essentially forced by necessity.
Okay.
So we have a high glide ratio. The aircraft's hard to slow down, so we couldn't slow the airplane down. Things like reverse thrust and stuff like this didn't exist yet, or at least in the code base. We needed ailerons up, flaps down to slow down, kind of like a traditional airplane.
Yeah.
Well, we spoke to Simon at the time and Andreas and Roman, and they were like, well, we'll code it for you. And they did it in 2 days.
Awesome.
And so that wasn't a feature on the Autopilot side, and I said, cool, I'll bring some airplanes and I'll be there next week kind of thing. And we had the requirement for that to actually work. They fulfilled the requirement so quickly that we've been on it ever since.
Awesome, that's great to hear.
Yeah.
And how long was this ago? Like 2014?
Yeah, maybe late 2014, early 2015, around then.
Okay. Wow.
Yeah.
So it's like 7 years?
Yeah.
Wow, that's a lot. And like half the time that the PX4 has been alive.
Yeah, and we've been on it pretty much, well, I would say exclusively. I mean, we've done a few tests here and there for certain things, but no, that's what we use.
And what is the Albatross being used for?
Okay, so this is interesting. About half of our uses are research and development, so schools, projects like this, and then the other side of it is defense, military, where the cost is so far less than other things out there that they are either used as disposable aircraft or single use or several uses, and that's it, and they replace and reuse, keep going.
Yeah, it's so fun that defense just basically looks at our platforms and are like toys to them because of the cost. Like you can just throw them away, even though they're like up to par with the same other like more expensive things they're using.
Absolutely.
It just changes the whole structure of how they work and operate with things.
It's one of those things where if someone's used to paying $250,000, $300,000 for something, and you say, hey, we can do that at a fraction of the cost, and if you crash it, or if you destroy it, or when you destroy it, or things like this, we'll just pop the sensor out, which could be quite expensive, and put it in the next one. Mm-hmm. You actually can make the unit cost relatively cheap for the end user who is abusing and using things that way.
Awesome. And how many units did you ship like in your first year?
First year, maybe like 40, 50, 60, something like that. We had a pretty big following back on DIY drones, right?
Yeah.
And people were really excited because there wasn't a lot of stuff out there. And so people were kind of anticipating and waiting. We were selling them at a loss. We just wanted them to get in people's hands and this sort of thing. So it was pretty steady and kind of then exponential growth from there. But yeah, in the beginning, I mean, humble beginnings starting in California, but we knew we could get there if we could get the software working and kind of go on that side of it. And it's been a lot of fun.
So you didn't have a goal other than, I know there's an opportunity here, and you got the product going, and you filled the market, then you got validation immediately.
Yeah.
So what happened next? Like, did you adjust or tune your goals? Did you set any?
Yeah, I mean, I think the idea is, or the idea was, I should say, is that the industry itself was kind of at its infancy. Originally, everyone said, hey, farmers are going to use these things all day long. That's kind of going to be and we said, okay, so we looked at kind of farming applications and this sort of thing. And then we realized, okay, well, different sides of commercial, and then drone delivery and things like that. So when you look at it from that perspective, the aims were always to say, okay, where do we fit best, right? And one was research and development. Schools, we supply aircraft to a lot of schools, and the other side being the military. So it really kind of was a shift on our side of doing things. And what's really interesting is something that we're doing right now is, so the FAA has their Assure program, and they've given quite a lot of money to a number of schools this past year. And what it's for essentially is right-of-way for figuring out beyond line of sight rules, what's going to happen right away at the end of the day. And we're supplying a large percentage of all of the recipients of their money, the aircraft. So they're going to be our aircraft, which is nice because they'll have Sage Tech's ACAS computer on board, which is an collision avoidance system, but it's going to also have Iris Automation's detect and avoid. So we're running with these two pieces of hardware to be able to see in real time cooperative versus non-cooperative aircraft.
Awesome.
And what that's going to do is that's going to let us figure out, hey, what is the correct way to do this, right? Because that's kind of what everyone's waiting for is beyond line of sight, at least in the U.S.
Yeah.
So it's really interesting to be part of that, but also we're supplying it to so many different schools. We get to see it from all different angles.
From my perspective as a developer, as an engineer, it's so crazy to think that drones have this capability of just being autonomous and flying anywhere in the world. You don't need to be present, but regulations and actual humans are what actually is holding down that innovation. And the fact that we actually have never even made tests in like scale, like you're mentioning, these challenges are great for that. So you can actually figure out what's missing. What's the missing piece here that is not actually being thought about or talked about?
Absolutely.
Much. And opening that discussion and like having an open collaboration in the ecosystem is really important.
It's necessity. I think it's a necessity. So this is all being, the program's predominantly going to schools. So we've got University of North Dakota, and we've got Embry-Riddle, and big schools that have big flight departments that we've been working with. So open source has been a requirement because, for instance, there's been a bunch of pull requests lately on PX4 open source, or upstream, I should say, of which we're huge advocates to keep everything upstream, so that way everyone can use it, everyone can benefit and change it. For Sage Tech's ADSB in and out, which is this ACAS computer. We wanted it to go there simply so that way, more developers could look at the code, make sure it was going to work. But that's what was required. I mean, we needed it to go this open source path so people could see it. But at the same time, when the data comes back in, it's going to be able to be shared with everyone to say, hey, look, from a transparency perspective, from a code auditing perspective, here it is. Here it is. Here's what you get, and here's what's going to come out of it. Yeah,
so open collaboration is not just about the source code in open source. No. Like it goes way beyond that because. And this is something that I like to repeat myself saying a lot of times every time I talk about this. Like, open source is not just the code. It's like the people behind it that is actually making this happen. And I like that everything that we're doing and we're like pushing forward. Like, and thank you for all your contributions. Thank you, because you're a huge supporter of paying developers and like contributing, pushing things back. And one of the benefits of PX4 is that, you can contribute everything you can, but if there's anything that's your IP, you can also like keep it to you.
Absolutely.
And like we don't need that. Like if this is something that is so specific to your use case and it's solving your problem, just keep it to yourself. Like you don't need to come back to us and say, and we're not going to demand it to, hey, where's your secret sauce? Otherwise, we're not going to share with you. No, not at all. Like we are not about that. We care about driving the industry forward, and that doesn't mean we're going to take away from your customers. The pie is so big right now that like there's enough for everyone. And question of the challenge, is this FAA back challenge going to inform any of the work groups or any other standards setting bodies?
I think so. I can't say definitively, but I would imagine so, given that there's so much money being spent through a wide variety of schools, all testing essentially the same thing, right? Right of way. How do we do this? How do we do it safely, right? So these aircraft will have ADS-B in and out, which need special exemptions from the FAA to use, at least out. They'll have collision avoidance for non-cooperative aircraft through vision-based system, and then we're also doing redundant C2 links, because that's another thing. What happens if your telemetry or your RC or whatever you're using
it just goes away?
Goes away. So that's another thing. They have it's called LSI Halo system, which is an unbelievable piece of hardware on there. So I would imagine that all this stuff will feed back into everyone, because it's a perfect example to say, here's what worked, here's what didn't work, here's what we need to change, and it's not one person doing it.
Yeah.
And it's a similar platform in every one of these cases.
Yeah, and I would like to highlight to the audience that it's not that the software is not capable of taking those decisions, it's that we as humans have not reached an agreement into what the decisions should be.
Exactly.
And that's the actual problem. It's not a tech challenge, it's more like let's make sure that we're all on the same page here and making this work. And question about that is Drone ID have any play into this?
Absolutely.
Of course.
I think the 16th, in 2 weeks?
Yeah.
No. So Drone ID Drone ID is coming, whether it sticks or not. Who knows? Right? We understand it. It is one of those things that it's going to have to get implemented very quickly, and there's a little bit of ambiguity about that. It will be part of it because it's required to be part of it.
Yeah. And
we'll manage that. It's relatively straightforward. There's a few things that kind of have to do, but
Drone ID has been in the back of our minds for years now, and by now that it's finally going to be mandatory to some degree, everyone's rushing to get something out together.
Sure.
It's whoa, didn't we have years to make this happen?
We just had this talk internally.
How come were we not ready yet? I feel there's a need in there for the whole industry as a whole. What happened? We're in this industry, I feel a lot of people talking down to the FAA and say, yeah, the FAA needs to get their stuff together, their act together, but hey, they've been telling us about this technology for a while now. How come you're not ready? Just challenge yourself to think about that, because I feel companies need to be honest.
Yeah.
And I've been saying this. The FAA or standard regulation bodies are not holding the industry down. Infrastructure is holding the industry down. We're not building enough in collaboration. We're not building the infrastructure ready, so that we can actually be out there and be able to work in a way that we get right access to the airspace, and we know who's got the right access of the way, and we can identify a unit whenever a flight goes wrong.
Yeah.
It's Applied Aeronautics vehicle, and it was this customer, and they were doing this, and this is the flight plan, and okay, so the authorities can come in, do an inspection.
That's how manned aircraft works, right?
Yeah.
Hey, look, there was a problem. This was the problem,
and all the pieces are there. But we're still to go there, and there's a little bit of frustration in this talk. We're really very passionate about this, especially you. I know you are, because we talk about this a lot. And so, what's happening in Applied Aeronautics besides this challenge?
Well, so we've been working a lot on things in the high reliability standpoint. So looking at fireproof and looking at things where how can we create aircraft that can work in more adverse scenarios, adverse weather, things like this. So we've been spending a lot of time on kind of R&D and sort of
extreme heat.
Extreme heat, this sort of thing specifically. That's been a big push for us, is to spend some time looking at different things like this.
Yeah. So you moved out of California, right?
Yes, Austin, Texas.
You're based in Austin, Texas, and I know that because we met in Austin, Texas for the PX for Developers Summit. By the way, Ryan spoke at the PX for Developers Summit, and his talk is now on the YouTube channel. Go make sure you check that out. It's a really amazing talk. I just listened to it the other day. And I want to highlight that I think it's one of the best talks, because it's actually talking about the industry, the thing that makes drones work in defense, and how did he face all those challenges to solve that. And you should check that out. So anything you want to talk to our audience about your video or your talk?
No, I think with the video specifically, I was speaking more, or really about how, practical use cases in kind of defense type situations and commercial situations, from not really an operator, which is not really what we are, but a manufacturer. And at the end of the day, we come in and we have to help people understand how to become operators.
Yeah.
So it's an interesting perspective.
Yeah, I like talking to you, Ryan, because you share one trait that I think I would like to say, at least, that I have, which is I get to talk to developers, but I also get to talk to business people.
Yeah.
And I get to talk to pilots. And I feel like it's like the perfect trifecta, so that you're in the middle of things,
Yeah.
and you got so much knowledge about pilots and so much knowledge about the industry. And I want to pick your brain a little bit about that. So,
Sure.
do you have in-house pilots that help you test your vehicles?
Well, typically we do. It depends on what type of testing we're doing.
Yeah.
So when we take, say, a PX4 PR, we'll classify it as high risk, medium risk, low risk. High risk goes on like a small foam plane.
Yep.
Crashes in the ground, doesn't really make a difference.
Yep.
After medium risk will go on to a sizable foam plane, which can be managed, but it's still quite large. And then low risk or lower risk will go on a
Production ready?
production ready aircraft that is still a test plane. So like we crash them all the time, we do stuff like that.
Yeah,
And
you keep repairing.
yeah, and then at some point they get put in the graveyard, hung from the hangar ceiling and things like this, that sort of thing.
Thank you for your service.
Thank you for your service. They like got epoxy on them and glue and stuff like that. But yeah, we sort of look at it from that perspective to do testing. It's got to be that way.
Okay, and do you have a sort of process where you collect logs, you look at any type of information that is important for you?
So a couple things. One, we found that with our use cases, given what you said earlier, that there are not a lot of us on the fixed wing side.
Yeah.
There's documentation and there's all this great stuff, but you kind of have to figure out what works for you, right? Mm-hmm. Hey, this is actually the best way to do things. This is documented, but this is really what works well.
Yeah.
So we will test our changes and things like this based on that information. And sometimes it's a big problem, because if you're doing something non-standard, but it works for you and you try something new. So we'll look at that data. We just always make sure that we don't have a degradation in, say, flight characteristics or flight performance. That's kind of our main thing when we're testing things. Functionality is great, increased feature set is great, but we've got to make sure we obviously don't decrease, flying long distances, long duration, that sort of thing.
Yeah, and I want to talk to our audience real quick, because mostly, like I said, we're talking about quadcopters and things, but what would you say, Ryan, is the number one difference between a multicopter and a fixed wing, and why does that matter?
Okay, so I'm going to answer this two different ways.
Yeah.
Okay, first way, when you are flying a quadcopter and you're actually flying it and you're not sure what to do, or you stop, you just let go of the sticks and it stays there. Right, it will just kind of hover around. You can sort of figure out what you want to do. That does not work with a fixed wing plane. It keeps going. It just keeps on going. So you have to really have a good plan, and that's a big part.
There's no position hold.
There's loiter, right? But even a big circular hold or a loiter it's pretty. I mean, it's a huge area.
By the way, there was a recent update which makes it so much better.
Yes.
Yeah.
Yes. And then so that's on the kind of technical side. But there's a huge difference in terms of what they're used for, right? If someone says, hey, I want to look at the side of this building and take photos, you don't want a fixed wing plane. You don't even want a VTOL, really.
Okay, so you're now looking at the different platforms for different verticals, for different problem solutions, like solving different problems.
Yeah.
So what type of problems do you solve with your platform?
So going back to the customer side, we've got the research and development space, and that can mean anything, like the FAA's Assure program with all these schools we're talking about, or other schools creating sensors, putting things on board, anything you can imagine. Military is also kind of a catch-all phrase, right? A big aspect of it is ISR.
Yeah.
Or training.
Reconnaissance,
right?
Yeah.
And that's because it's very easy to put a high-definition thermal camera on a plane with tracking and all kinds of cool stuff. That's great. It does that job perfectly well. So that's kind of been predominantly what's been used on the military side of things.
Yeah. So flight time?
Up to 4 hours.
4 hours.
Yeah.
Whoa. So like I don't know that people realize when you talk about flight hours of flight, the data collection out of that is just immense.
It's massive.
It's massive in the collection of data that you can get, and like the analysis you can do afterwards is amazing. But flying a vehicle for 4 hours instead of like 20 minutes at a time, it just allows you to do so much.
Well, exactly, and it's also quite taxing. Right, that means and a lot of people will fly for an hour and a half, 2 hours, come down.
Yeah, just like looking at the sun out there, like just.
It depends, right? A lot of times it's somebody looking at it, or if we've got BVLOS approval and things like this, which we've gotten quite a lot of.
Yep.
It's people, managing the camera on board or whatever they're kind of doing, this sort of thing. But it's a long time to be up in the air. I mean, absolutely. We actually had to host our own PX4 flight review, specifically because the logs are so big.
Yeah.
because what do you do with that much data and this sort of thing? So no, it's.
So do you have people in-house that actually know how to read the logs?
Oh, absolutely.
I'm not saying you don't know.
No. You have to.
Yeah.
In fact, it's something that we spend a lot of time doing is going through logs and saying, hey, did you catch this or did you not see this? Or here's what happened in this case. Here's what was great. Here's why you're changing elevation from 200 feet to 700 feet every 10 minutes. Of course, this is what's that sort of thing. It's a requirement. I think none of this is automated in our industry quite yet. From the perspective of how things can and should work, it's still up to how we set it up.
Yeah. So the Albatross has just been this one product, but it's had different generations.
Absolutely.
And I know this because you've shown me videos, but you keep on improving on the reliability of your aircraft and also on the materials that you're using.
Sure.
And the way you manufacture them.
Yep.
Can you talk a little bit more about that and why do you do that? Why is that important?
Well, I think starting with importance, it's important because you have to innovate, right? You have to keep things moving forward, changing, and kind of stay with sort of not only the times, but things change. We can hire, or we can hold heavier sensors, so we want to make the plane just as strong, but maybe lighter and things like this. So that's that side of it, and that means spending a lot of time in the research and development R&D side of things, saying, hey, if we change this material to that, what's the increase in cost, but what's the benefit or savings in weight, and sort of finding that nice trade-off, kind of sweet spot, like anything. So that's a really important thing. But going through these iterations, we stuck with the same name, so it was familiar with people, even if it's a generation 1 or generation 10 aircraft. And for the most part, they're pretty much all interchangeable. If there are certain things missing, we can kind of add them in or kind of adjust as needed. But it's been a labor of love.
What is your airframe made of?
So it's completely composite.
Composite.
Carbon fiber, fiberglass, fiberglass in areas that really don't need carbon fiber for strength and for cost and things like this, and then carbon fiber where it's required.
Yeah, no, and I think one of the important things about the fixed-wing vehicles is that you get durability, you get hardening with the materials, and then you get 4 hours of flight time. Just think about it, this platform can last 4 hours in the sky, but at the same time it can also last you 5 years. Because it's a durable platform, and the amount of flight time on a single vehicle, it's way more than what a typical multi-copter would have, even in the same time span.
So, which means we have to actually manage components. So from the perspective of saying, hey, how many hours are on this motor? How many hours are on this servo and things like
That's why it's important to have that data so that you can actually look at it and inspect it and tell your customers before they actually have the problem.
100%. And you have to create a pretty detailed maintenance program, just like an aircraft. And we have a maintenance program that says, hey, at 15 hours you need to start looking at this. At 100 hours you need to look at this and that sort of thing. Because at the end of the day, I think with the transition from hobby-based components to sort of more industrial-based components where, say, bearings might not be rated, you have to start creating those ratings.
Yeah. So what do you think is missing in the industry right now?
Well, one, we've always said, and this is probably more kind of on a global scale, we've always said it doesn't matter if there are strict regulations or difficulties to fly beyond line of sight. We just need to know what they are, and we will follow suit, implement what needs to be implemented, and get it done. So we want some kind of definition and some idea of what that's going to be. That's probably on the commercial side and really looking at the policy side of things. On the other side of it, and the technology side, it's not that things are missing, it's that we're still relatively new as an industry in terms of what we can do. Technology changes daily, hardware changes so frequently. Forget the chip shortage for a second, but we have the ability to alter and do more things that we really don't even know. We package delivery just sort of came out of nowhere. And so what's missing is probably more people coming together. I see a bigger benefit when people come back and say, hey, here's the data from what we did, here's what worked, here's what didn't work. We always like to provide the data back to upstream to PX4 and say, hey, we were dead reckoning, so we didn't have a GPS, or the GPS shut off. Here's the log. This is what happens. This isn't a simulator. This is what happened. And I think when you give that information back, it helps developers, it helps other companies, it really helps collaboration. It helps
share knowledge.
Yeah, absolutely.
Definitely. Yeah. And what would you say in terms of the technology? Where do you think things going in the fixed wing space?
I think we're going to see reliability increase through redundancy.
Okay.
So I think that's going to be a big thing. So I think especially as we get into a scenario where people are flying beyond line of sight or closer or around people, we're going to need to start looking at things kind of like aircraft.
Yeah.
And it might not be that things are type rated or things like this, but where a single failure point doesn't really exist, or at least the probability of that single failure point is relatively low. And it could be basic things like 2 airspeed sensors instead of 1, stuff like this, which is easy to do.
Yep.
Yeah.
And it's already supported, by
It's
the way.
already is supported, exactly.
So, reliability.
Yeah.
Also regulation.
Yep.
And do you think your platform is already capable of like handling some of that?
Absolutely.
Feature?
And it's not just the platform. You have to have 2 sides. You have to have the software, and the software is capable, and you have to have a platform that can integrate all that in, and the platform's capable.
Mm-hmm.
So I think that's already there. What's missing is some of the policy. That's okay. It's coming along. And then best practices. And you only get to best practices through trial and error. Right? That's it at the end of the day.
How many have you personally crashed?
Okay, 1 week many years ago, I think I crashed 3 in 1 week, maybe 4. 1 week. I did
That
have
was a good week.
That was I think it was 3. Let's just go with 3. But a million years back, before there was anti-stall code, right? So that I remember flying a plane, and it was actually in like autonomous mode. This would have been like 2016 or something like this, 2017. And it came in for landing, and it was autonomous, running PX4.
Yep.
And I remember my computer saying, flaring, so it's getting ready to shutting down the motor to flare. But it was at like 125 feet altitude.
Whoa.
Now it was in a safe location. We were testing something new. But those are the kind of things that you need to figure out why. You need to go through the logs, look at what's going on, go get back with developers, maintainers, and say, hey, what's happening here?
At a certain point, when I got started, like 11 years ago in the industry, crashing was a sign of success.
Yeah.
Because it meant that you were like pushing things forward. And nowadays, like crashing is like not being perceived as a good thing anymore. But to me, personally, I think the more we're crashing, it means like we're keeping things moving forward.
Well, you're testing things, right?
Yeah. And it's like we're finding new things. Yeah. And at least it didn't happen it happened in a control location, hopefully.
Yeah.
Fingers crossed you didn't fly in a dangerous area. No. Don't fly in dangerous area.
No, don't. Seriously.
Yeah, so do you foresee any future where you would like move into other platforms, like it may be a vertical takeoff and landing?
Potentially. I mean, we're working on a couple of other platforms right now for next year, maybe the year after. And we actually did build a vertical takeoff and landing aircraft. And we just kept having to settle with certain things we didn't like about it, which is, taking 4,000 watts of power to take off kind of thing.
Yeah.
And we've got this hugely efficient aircraft. It's like
a huge power draw.
It's a huge power draw. So there's a necessity, and as the necessity kind of gets there, then we sort of adapt as needed. But that's not the only way to do it. So
it's more like the use case then, as like how do you
Yeah.
use your platform to actually solve a problem, and then at some point maybe would you say that if it justified it, you would move into another platform?
Well, always, and I think what's interesting is a lot of times you can try things and see, okay, well, this is just a modification. Let's see how it works. Let's make a few, or let's make a few R&D versions and things like this, which we've done in the past. We've flown the VTOL Albatross quite a bit in Switzerland and places like this, and quite a bit in Austin, and it's cool. It takes off vertically, right, and it just gets up and goes. But
it exists then.
Yes, it exists. It's not been sold, but it exists.
Yeah.
We were actually planning on releasing it right before COVID started. Yes, it was actually
like a sign.
It was like going into production, and then everything shut down. And we're like, well, we're not going to release a new product in the middle of.
Nope.
Yeah.
Yeah, but now the Albatross is hugely successful.
Yeah.
Are you able to name a few of your customers?
Let's see. I would say a huge portion of U.S. and foreign-based schools. Take your pick, Embry-Riddle, UND.
Yeah.
So a lot of these schools. Most branches probably of the DoD, specifically, and I think we have a list on the website of customers we can kind of say, but it's a delicate.
I'm always being. That's why I put question as I did. I was like, I know especially in the drone industry, like there's a lot of companies that have their public facing work,
Yeah.
like you can talk about, and then the R&D stuff,
Yeah.
and then the other things that you can't. And let's be honest here, like a lot of the funding for the industry right now is coming by defense and the industry, and that whole sector has its own goals,
Yeah.
and it's sort of like, I wouldn't say it doesn't follow regulations as much, but it might not care when they have a goal in mind and have the purpose. So it allows you to.
Well, closed airspace, you can do whatever you want, right?
There you go. You said it.
That's the end of the day. At the end of the day,
I was just tiptoeing around it.
But no, but it's not even a bad thing, right? That's their airspace. They control it, things like this. I've been on site where we're flying 5-10 miles out with high definition links, and we're not doing anything wrong just because it's closed airspace, right?
Yep.
And it's pretty interesting to see that stuff. You want to know the only problem? It's not really a problem. The only thing that's unfortunate is those are logs that can't be shared.
Yeah.
So when you get all these really cool logs where you're like, hey, actually, this is five miles out. This is what goes on, and that's okay. But internally, you get a lot of data.
Yeah, there are flights happening.
Yeah.
It's just like it might not come back to open source as transparently maybe, but it ultimately ends up going back.
Well, your knowledge flows back, right?
Yeah.
Hey, this is what I saw in this case. This is
so
a real.
you should look at this, maybe more like a cautionary tale. Like
I can't give you the log, but I can tell you that we need to fix this or we need to address this problem.
Yeah.
And that benefits that user too, right?
So let's talk about then PX4.
Sure.
So you're using PX4 in the Albatross, and you're able to keep modifying your product.
Yeah.
And have you had to modify anything in PX4? For example, an even better question: do you have your own fork of PX4?
So we keep our own fork of PX4, but anytime we change anything, typically we push it upstream, or whoever's made the changes for us. Typically, it gets pushed upstream.
Yeah.
And I think the best example is probably the first example, where okay, the landing code was made, the takeoff code was made, the autonomous landing code, all this split, crow, split ailerons, all this sort of stuff, and it went right back upstream because that's not our business.
Yeah.
And if I can pay for it, not pay for it, but use it, and then you as a user or as another company could use that as well, that's better because then you're going to come back to me and say, hey, this worked, we saw this problem with this, and then we can make it iterates, right?
Yeah, there's a lot of ways to contribute back.
Exactly.
Yeah, like you can hire developers.
Yep.
You can share the knowledge like you're doing.
Yep.
Maybe you can sponsor an event.
Yeah.
You can be on the podcast talking about your experiences. And that's the advantage of being part of an ecosystem, a community.
Yeah.
By the way, thank you again for all your contributions. And would you say that PX4 has helped you and the Albatross be successful? Do you think it would be the same if you went closed source?
Let me back you up.
Yeah.
First question, do I think it's helped us? I'm going to say, not only did it help us, it made us. It wouldn't have happened any other way. It would not have happened if we went closed source because the time to market for software, things like this, would have been unknown. It could have been a month, great, but it could not work yet. So we are here because of open source, PX4. I'm really firm. I think I said that in my during the conference. 100%. We're here because PX4 enabled us to do it.
Yeah.
So absolutely.
Well, it goes both ways. Like you take the other day, I said this quote. I'm hoping that I'm going to say it right. You scratch my back, I scratch yours.
Yeah.
Look,
and it's not even like that. It's sort of inadvertently, right? Like, so if we hire a developer to do something, especially if it's non-core, something that we don't want people to know about yet, we'll push it back upstream, and then we can see how it works.
Yeah. And where I'm assuming you have some code modifications that you consider your IP.
Yeah.
Where do you draw the line? Like, how do you decide, hey, this is something that I think is going to push things forward for the community, and I'm going to push that, versus, hey, you know what? I think this is something that it makes us unique.
Well, that's an interesting one. So I think truly, when you start looking at it, we're a manufacturer, right? And let's assume you're a customer for a second. If you, the customer, can benefit, then generally given our position, we want you to have access to the code, and we typically want most people to have access to the code simply because most people end up modifying it themselves, and we say if we pay it forward and things like this, then you'll share with us. And so we typically don't distinguish too much. We tend to put everything back out there.
Okay.
Because we're a hardware manufacturer at the end of the day. So that's kind of a unique position.
And hardware is hard.
Yes, hardware is hard. Yeah.
Understatement of the year here, right there. Has the supply chain really affected you at all? And I know, I think I already know the answer, but I'm gonna let you.
So two things. One, on the raw side, so like doing our fabrication and production, not so much. We knew ahead of time kind of what was going to happen with raw components. We had a bit of an idea on the electronic side what was happening, so it was just a matter of supplying and stockpiling and things like this. If anyone tells you it hasn't affected them, they're lying. It absolutely has affected everyone.
Yeah.
It's just that it was happening slowly, or things are still available, they're just more expensive. So you can still get things, you just have to pay more for them.
Yeah.
So yes, it affects us, but we've been able to manage it just by taking alternate paths, looking at different things, maybe testing something you wouldn't typically have used before, which is nothing more than spending more time trying a new Autopilot to get it kind of up and working and that sort of thing.
Like the Pixel 6C.
Which is a big thing that we spent a lot of time on. Yeah, exactly.
Yeah, so moving from a platform, like you started Pixel 1, like the classic, like how many flight hours did you think, like not even in Applied Aeronautics, like in the whole world, like has like Pixel 1, like that's the why people keep using it, because it's just being proven again and again.
And if you actually, it's too bad because on the public PX4 flight review, I think a year or two ago, a lot of the logs they kind of got all cleaned out. But before, you could hit and you know what I'm talking about.
They're still out there somewhere.
Oh yes, I would imagine. But you could see how many hours of flight were actually, or logs and things like this, and it was by far the most. I mean, I
stopped looking at the amount of flight logs and flight hours we have in flight review because it's just like getting ridiculous every time. Like I used to have it on my pitch deck for PX4, like flight review, like hundreds of thousands of flight logs, just share knowledge, like. It's just redundant anymore. Like you just
lots, like McDonald's, billions and billions served. Yeah,
exactly. You gotta keep adjusting that number. Yeah. So we're nearing the end of the interview, but I do want to go to a round of fast questions. Sure. You say, and then I want to land on the last question. I'll give you some time to answer that. Okay. The first question is going to be more like first thing comes to your mind. Just go out there and say it, and let's not stop and discuss it until the end.
Okay.
And then we'll go from there, okay?
Okay.
So, what does the industry need the most, Ryan?
I think it needs a clear pathway forward for regulation. Plain and simple. Doesn't matter what it is, doesn't matter if it's difficult, doesn't matter if it's remote ID on steroids, it just needs something to be defined so that people can operate BVLOS safely. And whatever that is, we'll figure out. But we just need to know what it is.
Yeah, definitely. Yeah. And then in terms of the workforce, where do you see the biggest need?
In terms of work, do you say workforce?
Yeah, workforce.
I mean, the developers and the maintainers are crucial because they're the ones looking at your code, they're the ones putting new code out there and things like this. The other side of it is just equally as important is the companies testing it. Because you have to have both. So they're almost equally matched. Because if you have, if it's lopsided on one and the other side doesn't do it, nothing happens. If you've got a heavy side of development, but they don't do, or excuse me, of testing, but they don't do development, you get stagnation and you don't get kind of growth.
So you need pilots that actually know what's going on behind the scenes, so that you can actually go out there and test.
And they're almost not even pilots. They're more like. They are pilots, but they're more like software inclined pilots that are. It's a hybrid. Right? Understanding a bit of the code base to be like, oh, this is what we need to change quickly, but that's not what they do.
Definitely. So what advice would you give specifically to new developers looking to get started in their own industry and joining the workforce?
Well, I think first things first, ask a lot of questions. That's sort of, find something that interests you. And then from there, it's just about finding specifically what you want to do and how you can kind of make a change, help benefit what's going on, and then it kind of is all consuming. It sort of pulls you in. Making something fly, a flying robot at the end of the day is pretty intriguing. So my advice would be to take a look, see what interests you, and just follow it, because it will take you.
Awesome. And what's the tool set that you think candidates need to bring to the table?
So we had this employee one time, and he had a 107 license. And I said, hey, that's cool, so what do you fly? And he said, oh, I've never flown anything.
What?
And I said, well, why do you have 107? And he said, to get a job, or to help get a job.
Yeah.
And I said, That's so funny. Okay, so you've got to actually know how to fly one of these things before, we're going to put one by
So
you.
he passed the test. Well, because
He was a full-size pilot. I'll give him that.
Okay.
From Austin, but he was, and so he.
Well, for a pilot, the Part 107 test is a joke.
Exactly.
Yeah.
So it was easy for him. But if I didn't know that, and I said, well, go take a plane out tomorrow, right? That's a scary proposition. So to answer your question, practical understanding, right? There's a big difference even in flying a quadcopter or a multi-rotor versus an airplane.
Yeah.
So some practical understanding of kind of how these vehicles operate. They're dangerous, they're safe, depends on kind of what you're doing. And then it really does help to have a bit of an understanding of a little bit of the software, not necessarily the coding, but how things work.
Awesome. Yeah. And how has the open source community matured since you joined the ecosystem?
I think one thing is it's just getting larger, right? And that's great. So how has it matured? I mean, you see some people kind of forking things off and hiding it, and that's totally fine. We get that from some of the smaller companies that want to do specific things, but you truly see the benefit when people start, even if they're keeping their own stuff, they're sharing it back. So we've seen that mature quite a bit.
Yeah. What do you think is the future for the community?
More collaboration.
More collaboration.
Absolutely. I think there'll be a point where the vast majority of it is collaboration, and then say you're doing something very specific on like an off-board mode on like a computer. Maybe that stays a little bit more private if you've got, like you said earlier, some secret sauce or something like this. But you'll start to see more collaboration kind of with everything that's and it makes sense.
It does.
Yeah.
Yeah, that's the way to go. That's the recipe to be successful in open source. Sure. Last question, and feel free to take your time on this one. What is the one thing that you think most people don't know about Applied Aeronautics, and that you think they should know? And put your sales pitch in here, sales hat here, and do your pitch. What do you think is the most important thing about Applied Aeronautics? What sets you apart? Okay.
So sales pitch. What sets us apart? And there's a couple things. One, forget the fact that we're a fixed wing. There's not a lot of us out there that make aircraft, like actual airplane aircraft. But what sets us apart is our ability and willingness to work with customers, right? Our mission is only successful if you're successful. End of the game, that's it. That's all it comes down to. So if you've got a complex use case, we will go above and beyond to figure that out, help you get it to actually execute and things like this. The platform itself is highly capable, and that's very important. So maybe you're putting way more weight than we rate it to and things like this, but you're able to do something you couldn't normally do. So capability from that perspective is very important. And the other one is cost. We're a fraction of the cost of kind of our closest competitors, and we plan on staying that way. And so you start putting all these things together, and that's one of the kind of differentiating factors about us. It's not one thing, it's kind of a multitude of these factors that we will help you figure out what you need to get figured out to make it work, regardless of what it is. And we'll go above and beyond because, our mission is your mission. That's it, right? We want to get it, we want to make it work, and we will make it work for you. Yeah.
Message to our community, anything that you want to say to our audience right now?
Sure.
Like the whole PX4 drone code ecosystem is watching?
Well, first things first, I want to say thank you. I think that's always where we start. We wouldn't be here without everyone, small and large, people that help, people that contribute from the top all the way to the bottom, and there really is no top and bottom. So first thing is thank you. What I want to say is, I am proud to be part of it. I'm happy that we are involved, and I really look forward to staying involved and increasing our involvement with the community. It's been a really fun experience. It's been a wild ride. And look where we are, right? All from, how could you ask for anything better? So just keep at it, everyone. I mean, everyone.
For another decade of open source and technologies in the drone industry. Yeah. Well, Ryan, thank you for helping us make this a success and being part of a community. For our audience, thank you for watching through the whole episode. Make sure that you don't forget to like, subscribe, and hit the notification button on there. And make sure you go to our YouTube channel and go browse through a whole collection of YouTube podcast episodes and tutorials and videos that we have for PX4 and drone ecosystem community. And that's it for today. Thank you again, and stay tuned for the next episode. Talk to you soon. Goodbye.